Kepler-22b stands as one of the most captivating exoplanets ever discovered by humanity. It possesses all the necessary conditions to potentially be a new Earth. However, its many mysteries could also make it a bizarre world beyond our wildest imagination. It could be a place full of surprises, or it could be our worst nightmare. What secrets does this distant planet hide? And what kind of life could be nurtured within its unique environment? Let us embark on a fascinating journey of exploration into one of the most mysterious planets in the galaxy. In 2011, during its survey of the cosmos, the Kepler Space Telescope made an epoch-making discovery. It found a planet located within the habitable zone of its parent star, named Kepler-2b. The telescope employed an indirect detection method known as transit photometry. Whenever a planet passes in front of its parent star, the star's brightness dims slightly. This minute change in luminosity becomes the evidence of a planet's existence. This method not only helps us discover planets, but also allows us to calculate their size, orbital period, distance from the star, and even the presence of an atmosphere. Kepler-22b's parent star is named Kepler-22. It is a yellow dwarf star very similar to our Sun, with roughly the same mass, radius, and age estimated to be about 4 billion years old. However, Kepler-22 is about 20% dimmer than our Sun. Consequently, it cannot be seen from Earth with the naked eye. This star lies approximately 635 light-years away from Earth. Converted into distance, that is roughly 3 quadrillion kilometers, or about 1.8 quadrillion miles. The distance between Kepler-2b and its parent star is also quite special. Its orbit is 15% closer to its star than Earth is to the Sun. If Kepler-2b were in our solar system, its orbit would be situated between Earth and Venus. In that scenario, the Sun's intense radiation would likely turn it into a scorching, desolate world like Venus. However, the situation on Kepler-2b is entirely different. Because its parent star is 25% dimmer than the Sun, Kepler-2b receives significantly less heat than Earth. This makes it possible for its temperature to be similar to Earth's, provided its rotation mirrors ours. If Kepler-22b's axial tilt is extreme, like Uranus, effectively rolling on its orbital plane, its climate would be incredibly volatile. It would manifest freezing winters and blistering summers. However, there is an even more peculiar possibility. The planet might be tidally locked. This means one side perpetually faces the star, while the other remains forever in darkness. This uneven distribution of light and heat would create unique environmental conditions across different regions of the planet. It would also dictate where life could be born and where it could flourish. If Kepler-2b is indeed tidally locked, the side constantly bathed in light might be the optimal environment for life. Here, the star's eternal light would provide continuous energy. Oceans might regulate the temperature here, preventing overheating. Organisms living here might absorb energy through a process similar to photosynthesis on Earth. However, problems would arise. If the planet's surface is covered in water, evaporation on the illuminated side would intensify. This could trigger a greenhouse effect, subsequently causing climate instability. This steam could exert immense pressure on the atmosphere, forming thick cloud layers. This would lead to violent storms and extreme temperature fluctuations. In such an environment, the survival of complex life forms would become extremely difficult. The challenges for biological survival here would be immense. If Kepler-2b is tidally locked, the other side would remain in eternal darkness. Imagine, in this perpetual night, could life exist? At first glance, it seems impossible. But Earth has already proven that life can survive in extreme environments. On the dark side of Kepler-2b, life might rely on chemosynthesis rather than sunlight to obtain energy. Chemosynthesis is a process where energy is released through chemical reactions. We have discovered microorganisms in deep-sea hydrothermal vents on Earth that survive in exactly this way. These microbes could form the foundation of an ecosystem on the dark side, feeding on chemicals spewing from the planet's depths. Furthermore, over time, animals on the dark side might evolve bioluminescence. They could use light to attract prey or to communicate, In this dark world void of sunlight, the light emitted by living creatures might become the key to their survival. Nevertheless, imagining complex life evolving on the dark side remains a huge challenge. Earth's polar regions and deep oceanic abysses do host unique creatures, but we have yet to discover similar life forms elsewhere in the universe. Therefore, at present, we can only use hypotheses to paint a picture of life in this darkness. Finally, the most mesmerizing part of Kepler-22b is arguably the twilight zone. This is the region located at the boundary between the light and dark sides. Scientists believe this may be the most suitable place for life to exist. Temperatures in the twilight zone might be stable enough to maintain liquid water, provided the planet has an atmosphere. In this band, due to the balance between warmth and cold, water bodies could remain liquid. This could form rivers, lakes, and even oceans. The interplay between intense evaporation from the light side and cooled air currents from the dark side could create a climate suitable for life here. Scientists speculate that the earliest forms of life might originate in the twilight zone. From there, they would gradually expand to other regions of Kepler-22b, just as organisms on Earth adapt to polar or deep-sea environments. In this most temperate region, life might gradually adapt to the extremes of the light and dark zones, evolving unique survival strategies. Although we still cannot confirm the specific conditions on Kepler-22b, the scenario presented by tidal locking offers rich research opportunities. Whether it is the day side, the night side, or the twilight zone, each region holds different potential for life. However, scientists believe the twilight zone is the most likely location to nurture a complex ecosystem. Future exoplanet research may one day unlock the mysteries of planets like Kepler-22b. Perhaps we will discover the first extraterrestrial life within this balanced zone. This assumes Kepler-22b possesses an atmosphere similar to Earth's, and that a mild greenhouse effect keeps its surface temperature at a comfortable 22 degrees Celsius 72 degrees Fahrenheit. However, it is also possible that its atmospheric composition is entirely different, or that it has no atmosphere at all. Without an atmosphere, the surface temperature could drop to -8 degrees Celsius. But if Kepler-22b has an atmosphere like Venus, filled with dense gases like carbon dioxide, its surface temperature could skyrocket to an unbearable 460 degrees Celsius. Fortunately, studies suggest Kepler-22b may possess an ocean. This could help regulate temperature, just like Earth's oceans, storing summer heat and distributing it evenly. Scientists also believe Kepler-22b may have abundant water resources. It might even host a global ocean with an average depth of about 180 meters. Although this appears shallow compared to Earth's oceans, remember that Kepler-22b is 2.4 times the size of Earth. Therefore, if you were to visit this planet, your primary challenge might be finding land. Dry land might be far scarcer than on Earth. If you were lucky enough to find land, another challenge would be moving around on it. The gravity on Kepler-22b is the second unpleasant surprise. Kepler-22b is about 2.4 times the volume of Earth and 36 times its mass. Scientists estimate its gravity would be 6 times stronger than Earth's. If you weigh 175 pounds on Earth, your weight on Kepler-22b would hit 1,050 pounds. Standing would be nearly impossible, let alone moving. Not to mention your spacesuit, which usually weighs about 300 pounds on Earth. On Kepler-22b, that weight would soar to nearly 1,800 pounds. Before we can travel to this planet, engineers on Earth would need to develop specialized exoskeleton suits. These would be needed to support your back, legs, and arms, alleviating the immense pressure caused by gravity. Without this technology, your journey would end the moment you stepped out of the spacecraft. And never, ever think about falling down. Even a small depression in the ground could cause a fatal accident. Falling into a 50-meter deep canyon on Kepler-22b would see you hit the ground in less than a second at speeds exceeding 190 kilometers per hour. You would never get up again. Gravity affects not only you, but every living thing on Kepler-22b. Plants that would likely be short and stout. They would possess thick, hard stems to resist the crushing pressure. Despite restricted growth, leaves and branches would be dense and compact to minimize damage under constant gravitational stress. To anchor themselves, plant root systems would likely be incredibly complex and deep. This structure would enhance their resilience, allowing them to maintain their form and survive in a high-gravity environment. The only creatures that might reach giant sizes are aquatic algae. They are influenced more by water buoyancy and are therefore less dependent on gravity. However, regarding this point, scientists cannot yet fully confirm the existence of an ocean on Kepler-2b. Thus, the composition of any water remains unknown. Even if water exists, we had better wait to analyze samples before attempting a dive. If you could adapt to life on Kepler-22b and planned a long-term stay, you would need to prepare for more frequent birthdays. A year on Kepler-22b is only 290 Earth days, significantly shorter than a year on Earth. But perhaps the most fascinating aspect of exploring this twin Earth is the potential discovery of complex multicellular life forms. This hypothesis is not without basis. If Kepler-22b possesses an atmosphere similar to Earth's and its axial tilt mirrors ours, it is almost guaranteed to have a stable, habitable environment. The planet sits right in the Goldilocks zone, suitable for life. Temperatures are not so low that it is covered in ice, nor so high that it becomes a fiery hellscape. Furthermore, if an ocean truly exists on Kepler-2b, it would further prove it is a planet capable of nurturing complex life. The critical question is, if there is life on Kepler-2b, what would it look like? Given the powerful gravity, we can assume creatures living on Kepler-2b have fully adapted to this environment. Much like the plants, their bodies would not be overly large. Instead, they might resemble multi-legged reptiles, designed to better distribute weight and facilitate movement. These creatures would likely be short, muscular, and stocky. They would possess powerful limbs specifically designed for walking in a high-gravity environment. Their body structures would be optimized to minimize energy consumption when moving through complex terrain. To cope with environmental pressures, many species might develop exoskeletons or tough skin. These exoskeletons would be extremely dense and sturdy, yet maintain enough flexibility for movement. Their material might be similar to keratin or calcium, but reinforced to withstand greater pressure and stress. Exoskeletons would not only protect these creatures from external injuries and predators, they would also help maintain body shape, preventing deformation under immense gravity. The exoskeleton might even possess temperature-regulating functions, especially if the planet experiences extreme temperature shifts. We can speculate that larger creatures would likely live underwater, where the influence of gravity is reduced. As for flying creatures, due to the intense gravity, they would be almost impossible to find in the skies of Kepler-2b. Nevertheless, these are merely models and hypotheses proposed by astrobiologists and planetary scientists. Theories put forward by NASA and other research institutions. Today, we cannot yet verify these hypotheses through observation. However, we hope future technology will allow us to study Kepler-2b more deeply. Perhaps we can reveal whether there are truly traces of life. If the assumptions about gravity ultimately prove wrong, and Kepler-2b's gravity is only twice that of Earth, the possibility of human colonization increases dramatically. In that case, the only major obstacle is distance. It is 635 light-years away. On a cosmic scale, this distance is negligible. But given human capabilities, it is almost insurmountable. The current record for human flight speed is held by NASA's Parker Solar Probe. This probe reached speeds of nearly 430,000 kilometers per hour as it approached the Sun. That is equivalent to 119 kilometers per second. Although this seems incredibly fast, it is actually only 0.064% of the speed of light. Even at this speed, traveling to Kepler-2b would take nearly 992,000 years. For anyone who dislikes waiting an eternity, this is clearly not an ideal option. Therefore, we urgently need a completely new approach. NASA scientists are currently dedicated to solving this puzzle. Experts are exploring propulsion systems based on concepts like nuclear fission and nuclear fusion. Theoretically, these systems could accelerate a spacecraft to 10% of the speed of light. This would be a considerable speed, 62 million kilometers per hour. However, even at this velocity, flying to Kepler 2b would still take 6,350 years. For the time being, unless we find a revolutionary method of interstellar travel, colonizing such distant planets remains a distant dream. The ability of life on Earth to survive and reproduce in extreme environments has proven something important. It shows that even on a seemingly unsuitable planet, life has the potential to be born and thrive. Next, we will turn to other exoplanets discovered by the Kepler telescope. We continue to move forward in the search for potential habitable planets. Scientists are looking for terrestrial planets, attempting to find Earth's twin. Those planets that are extremely similar to our own Earth. So-called terrestrial planets are bodies primarily composed of rock, similar to Earth. These planets have a higher probability of possessing a solid, rocky surface. Furthermore, it must orbit a star similar to the Sun. A star whose size and radiation output are close to our Sun's. At the same time, the planet must reside within the habitable zone. Kepler 452b was the first such planet discovered. A terrestrial planet orbiting a Sun-like star, it could be an ideal habitable world. Back in 2015, scientists considered it the most Earth-like planet discovered to date. This belief stems from the fact that the star it orbits, Kepler 452, is very similar to the Sun. Both are geek-type stars, with nearly identical temperatures. The only difference is that Kepler 452 is 1.5 billion years older than the Sun. Although this star is slightly brighter and has a somewhat larger diameter, the solar energy reaching Kepler 452b is almost the same as the energy Earth receives, with a difference of only about 10%. Kepler 452b is located within the star's habitable zone, at a slightly greater distance, about 1.05 times the distance between Earth and the Sun. Kepler 452b may possess carbon dioxide concentrations similar to Earth. If this is true, it is possible it could support life. Since we are on the subject, we cannot help but ask, if humans could live on this alien planet, what would the situation be like? Because Kepler 452b has a greater mass than Earth, its gravity would be stronger. In such an environment, human body weight would be significantly heavier than on Earth, roughly double. Initially, humans might encounter difficulties with movement, but over time, the human body would gradually adapt to this new gravity environment. This sets the stage for the process of natural evolution. Humans living in a high-gravity environment for the long term would become physically stronger. Our bones would become denser and more resilient to withstand the powerful gravity. As generations pass, new infants would be born with stronger physical constitutions than Earth-born babies. However, not all changes would be obvious. Thanks to Kepler 452b's distance from its Sun, its lighting and surface temperatures would be similar to Earth's. Just like Earth, plants on this planet would rely on photosynthesis as their primary energy source. The speed and intensity of growth might be similar to Earth. Scientists also speculate that this planet might possess a thick atmosphere, surface water, and active volcanoes continuously erupting. If these predictions are confirmed, Kepler 452b is undoubtedly a strong candidate for Earth 2.0. However, this habitable environment might not last much longer. Researchers believe that in 500 million years, Kepler 452b may suffer from a worsening greenhouse effect. Similar to the situation on Venus, the excessive accumulation of carbon dioxide will cause the atmosphere to expand abnormally, leading to a drastic rise in temperature. Nevertheless, 500 million years is enough time for humanity to explore and colonize this planet. Kepler 452b is an exciting planet, but it is not the only one in the Kepler series showing potential. The universe may host many worlds similar to Kepler 452b. Located 500 light-years away in the constellation Cygnus lies the Kepler 186 system. There resides a red dwarf star. It is within this system that scientists discovered the first Earth-sized exoplanet, orbiting a distant star within the habitable zone. Since then, astronomers have firmly believed that multiple planets similar to Earth exist in the universe. Planets with diameters comparable to Earth and conditions suitable for liquid water. Kepler-186f is less than 10% larger than Earth in volume. Its orbital period is 130 days. This alien world sits at the outer edge of the habitable zone. Consequently, it receives only 1/3 of the solar radiation that Earth does. This makes its environment closer to that of Mars. However, precisely because of this difference brings a unique advantage. Red dwarf stars are famous for their intense solar flares. These flares can triple the star's brightness within minutes. Despite this, the Kepler-186 star itself is smaller and cooler than the Sun, and far less luminous. Therefore, even with frequent radiation outbursts, Kepler-186f may remain safe from these lethal radiation shocks. Regarding the existence of liquid water and the possibility of life on Kepler-186f, it depends on more than just distance. It is also heavily influenced by the state of its atmosphere. Based on current conditions, Kepler-186f's surface might host frozen water. However, its larger size suggests the planet has a denser atmosphere than Earth. This atmosphere could better retain and distribute heat, potentially keeping water warm enough to stay liquid. The other 4 planets in the Kepler-186 system are only about half the size of Earth. Their orbital periods are short, making these planets extremely hot and unsuitable for life. Today, reaching Kepler-186f would take about 780,000 years. But imagine, in the distant future, if we could invent spacecraft capable of traveling at 90% the speed of light. Then, in about 550 years, our descendants might set foot on this planet. So, what would a future human expedition look like? The red dwarf Kepler-186 is smaller than the Sun, with a brightness about 1/25 of our star. If you stood on the surface of Kepler-186f at noon, the brightness of the star would look similar to the light 1 hour before sunset on Earth. Scientists state that Kepler-186f maintains a stable axial tilt. This allows it to have regular seasonal changes and a stable climate, similar to Earth. According to calculations, Kepler-186f's axial tilt has remained stable for tens of millions of years. This stability is crucial. If a planet's axial tilt is unstable, its climatic conditions can change drastically, rendering it uninhabitable. For instance, Mars may have undergone extreme climate shifts due to the instability of its axial tilt, eventually becoming the desolate landscape we see today. In 2020, Kepler-1649c was discovered accidentally while reviewing past observational data. Initially, it had been misidentified as a false positive. We still know very little about Kepler-1649c, particularly its atmospheric composition. But since Kepler-1649c receives about 75% of the sunlight Earth does, and its orbital period is only 19.5 days, its temperature might be similar to Earth's. If Kepler-1649c lacks a greenhouse atmosphere, its surface temperature would be -38 degrees Fahrenheit. Although this temperature seems unfriendly, Earth without greenhouse gases would also face low temperatures near 0 degrees Fahrenheit. Even if the atmospheric composition of these two planets is similar, Kepler-1649c would still need more greenhouse gases to bridge this gap. There are many Earth-like worlds in the universe that bear striking resemblances to Earth in both temperature and size. Examples include TRAPPIST-1f, TRAPPIST-1d, Teegarden-C, and TOI 700d. These exoplanets are relatively close to us. However, reaching Kepler-1649c still seems out of reach. Spanning a distance of 300 light-years makes it seem untouchable. However, if one day we can traverse these vast starry skies on a journey full of hope, this destination will be worth it. Because these nearby planets cannot compare to the unique combination of features Kepler-1649c possesses, Kepler-1649c is not only similar to Earth in temperature and size, but it also sits squarely within the habitable zone. This makes it a truly extraordinary discovery. With the advent of next-generation astronomical observation facilities, we will gain more clues about whether these planets are habitable. Meanwhile, we continue to explore another impressive celestial body. It is located about 1,100 light-years away in the constellation Lyra. Kepler 442b orbits a K-type star every 112 days. Its distance from its star is about half the distance between Earth and the Sun. Such close proximity could pose a threat to any potential life forms on the planet. Typically, planets orbiting this close to a star would be tidally locked, leading to harsh surface environments. However, Kepler 442b is located far enough away that it is well out of tidal locking range. K-type stars are dimmer than the Sun, and the Kepler 442 star itself is smaller and cooler. Therefore, the environment of Kepler 442b is in a relatively ideal state, orbiting at about 0.4 astronomical units. Scientists believe that K-type stars represent an ideal balance in the search for habitable planets. Although not as bright as G-type stars, like our Sun, and lacking the extreme longevity of M-type red dwarfs, they offer very favorable conditions. Within 100 light-years of our Sun, there are at least 1,000 K-type stars. These orange dwarfs can have lifespans ranging from 15 to 45 billion years. In comparison, our Sun has a lifespan of only about 10 billion years. By the end of our Sun's life, Earth will no longer be habitable. Astronomers often classify planets based on their potential habitability. The updated habitability index is more comprehensive than previous methods. It evaluates planetary habitability by considering multiple factors. This index looks not only at the planet's composition specifically favoring rocky planets but also at the eccentricity of the planet's orbit. Orbital eccentricity affects the stability of the light and heat the planet receives from its star. Additionally, the habitability index takes albedo into account. This metric measures the solar energy reflected by the planet's atmosphere. The habitability index ranges from 0 to 1. A higher value indicates a greater potential for habitability. On this index, Kepler 442b has been given a score of approximately 0.84. However, regrettably, this exoplanet is too dim and too small to be directly imaged by current telescopes, let alone interstellar travel. Even the fastest space probe would need 1.7 million years to reach Kepler 442b. What we can do currently is study its biosphere. A study once analyzed the radiation levels of potentially habitable exoplanets. Kepler 442b stood out prominently. The sunlight it receives is sufficient to support a significant biosphere. This biosphere might be detectable by the James Webb Space Telescope. As the Webb telescope observes this planet further, we also hope it will cast its gaze toward other intriguing exoplanets in the same constellation. These two planets are located in the Kepler-62 system. The other three planets in the Kepler-62 system are too close to the star, resulting in surface temperatures too high for life. Scientists are particularly focused on Kepler-62e and Kepler-62f. These two planets are likely water-rich worlds. Their Earth similarity indices are 0.83 and 0.69, respectively. Kepler-62e has an orbital period of 122 days, while Kepler-62f's period is 267 days. The atmosphere of Kepler-62e is thought to be covered in thick clouds. Its climate is likely warm and humid, possibly extending all the way to the polar regions. These climatic conditions make it an extremely suitable environment for life. A 2014 study proposed that Kepler-62e might possess a large moon. If this hypothesis holds, the likelihood of the planet being a habitable world increases further. This is because large moons are crucial for the evolution of complex life. Through tidal forces, they help regulate the planet's rotation and axial tilt. This directly influences climate patterns. A moon can also provide a protective shield, deflecting or absorbing impacts from asteroids or comets, thus safeguarding the planet and its life. Although the more distant Kepler-62f has a lower surface temperature, it remains potentially suitable for life. However, even if this hypothesis is true, considering the lack of metals or fire-starting elements resources, crucial for technological progress. Forming a high-tech civilization there seems unimaginable. Yet, the complexity of nature persists. Perhaps creatures more creative than us will emerge, surpassing our technological achievements in other ways. Perhaps they can even survive and thrive underwater. If humanity decided to send a message via the Parker Solar Probe to any intelligent alien life that might inhabit these strange worlds, they might receive the message, but it would take at least 1.85 million years. However, if we sent a radio signal today, it would reach these two exoplanets within 1,200 years. On the grand scale of the universe, this is merely the snap of a finger. Although Kepler-62e and Kepler-62f are not currently ideal Earth twins, the dynamic nature of planetary systems means these planets may undergo changes. Our planet was once completely covered by oceans. But, over vast periods, it gradually evolved into a diverse world with both land and sea. Researchers are considering the future evolution of these exoplanets. They speculate that they may eventually transition into Earth-like environments, forming a harmonious coexistence between vast lands and oceans. Meanwhile, if life truly exists on these exoplanets, it might be incredibly complex and sophisticated. One of the greatest challenges in studying distant planets is the immense distance between them. However, we may not have to wait for hyper-advanced telescopes to solve this problem. Data from the Kepler mission and the European Space Agency suggests something profound. Among all Sun-like stars, half may possess potentially habitable rocky planets. And some of these celestial bodies might be right in our cosmic neighborhood. This implies there is at least a 95% probability that an Earth twin is hiding within 20 light-years of us. The universe is vast, and our search for a second home has only just begun. If this journey across the stars sparked your imagination, please leave a like to help our signal reach further into the void. To ensure you never miss a discovery hiding in the deep dark, hit that subscribe button and join our voyage. Share this video with a fellow explorer who looks up at the night sky and wonders, what if? You are listening to Interstellar Whispers. Until next time, keep your eyes on the stars.